although we already had the differences between each pair of treatments, you can do that another way using this estimate statement. So with this you can be very specific about what you want to get the difference between. So here we're saying difference between treatments A and B across all time points, and we give these coordinates. We've got 4 treatments analysed, and we say we want the first one minus the second one, and it'll give us the estimates of that. By adding in this E thing into the estimate statement, it tells you more precisely how it's calculated the estimate from the model. So this row 1 column says that it's taken A minus B, but what it's also done, because there's an interaction in the model, it's had to take into account all the interaction terms, and because there's 6 time effects, it's going to be sort of plus a sixth of A minus a sixth of B, and so on for at the first time point, the 24-hour time point. Same thing for the 48-hour time point and each of the other 6 time points. So it's quite helpful to add this E thing in if you're interested in seeing exactly how the estimate has been calculated. You might want to get the first treatment minus the mean of the next 3 treatments. So you can do that by saying it's easier. What you really want is 1 for the first treatment minus a third of each of the secondary treatments, but it's actually easier to do that with a divisor term. So you say I'm going to divide them all by 3, and then you use 1 minus 1 3 times, so you don't have to bother with putting in fractions. So we've now got 2 estimates, so there are 2 in the list, and if we do the same thing, check how that estimate was calculated. It's a bit more involved this time, so it's 1 minus a third of each of the secondary treatments, and then at each time point it needs to divide these by 6 because there's 6 time points, and it needs to take into account the interaction term. So we've got a 6th treatment A here, and then this is for these next values. The 0.056 is actually a 6th multiplied by a third. Always takes into account the interaction in the correct way when you have an estimate statement. You don't actually have to put in the interaction, it knows it was already in the model. You might want to just get the treatment difference at one of the time points. So for example at 24 hours, which was the first time point, so we could add this statement in here. So now we need to bring in the interaction term. We've said the treatment is 1A minus B and nothing for C and D. And we now need to pick it out at the first time point by having a 1 minus 1 coming in here, and all the other time points are 0. And it adds it in as a row here. And helpfully, it's helpful to do this, add this E option and see exactly what's been calculated, how it's been calculated. So you've got the A minus B coming in as the main effect. And then just at 24 hours, you've got A minus B. So you've got the relevant term from the interaction coming into the calculation as well. You can also do that at another time point. If we do it at the next time point, 48-hour time point, we get the estimate for that, and using the E option you'll see that it's now picking out the second time point. So it's quite nice to be able to pick out exactly what estimates you want, and that's something that if you even try and fit a simple model in the likes of Minitab, you can't customize exactly what you want from the terms of the estimates from the analysis. So SAS is quite strong from that point of view.